Hello everyone, welcome back, and I hope you have a great summer. Today we are going to talk about the production and application of biofertilizer from food waste digestate. And here, this is just the processes that we are going to talk about today and why it's important to process the digestate into biofertilizers. As we discussed before, that the anaerobic digestion is a process for biodegradation of organic material in the absence of oxygen and producing the methane, carbon dioxide, and of course, some kind of volatile fatty acid. Besides these products, you will actually find also the liquid fraction or the liquid stream from the digester, which is, we call it digestate. The digestate is basically contains a lot of water, of course, and it also contains many elements of nutrients and salts, and it also can also have some organics that didn't actually digest it or through the process, or it can also contain some kind of inert materials like dirt or maybe something like inorganics that it actually also can be found in the feed material. Or the influent material or the feedstock that you are digesting. Again, this is digestate, contain a lot of nutrient. It has nitrogen in the form of ammonia, and this is why we mentioned before that the organic nitrogen, like in protein, it's actually converted to inorganic form, which is ammonia. And this digestate is good organic fertilizer or biofertilizer, and it has also potential to suppress insects that can cause plant diseases. Again, this digestate can be either surface applied to the soils or injected. This is basically simple methods, or it can also be processed into liquid and solid streams or solid and liquid biofertilizer. So basically, it will be it will be also easy to manage the fertilizer. Basically, if you have nutrient in the liquid form, you can actually apply by drip irrigation, for example. And if you have solid fraction, you can just apply with regular applicators for solid fertilizer or like manure applicators. Okay, so how we are going actually to process digestate? If we have here organic material goes through anaerobic digestion, basically again producing, of course, biogas that can be used for electricity generation, for example, or upgraded to natural gas. And this is the effluent. This is what we call digestate. And we have to remove the coarse fraction, which is basically fibrous material. And this coarse fraction can be used for other uses. Maybe you can recycle back to digester if needed, or you can actually treat this solid fraction with some kind of chemicals to increase its digestibility, because still actually also it may have also some potential to produce more biogas, or it can be dried or composted directly and be used as fertilizer, as soil conditioner. After that, this liquid fraction basically can be can be done through membrane filtration, and this membrane filtration can produce concentrate as first fraction and permeate. The permeate and the concentrate, of course, this is two streams that can be separated, and this can be stored, of course, until used. You can actually use the concentrate or permeate as separate streams with different characteristics, as I will mention in a minute. And this can be used as liquid fertilizer, biofertilizers, in drip irrigation. For example, here we are actually providing or presenting an example for tomato cultivation. The concentrate can also be dried, like maybe in a greenhouse or similar kind of dryers. And this dried material can be milled and then can be squeezed or can be condensed into pellets or biofertilizer pellets. And also this can be, this is a pellets here, can be used for example, as planting for corn. Basically, instead of using a manure or other organic pre-planting conditioners, you can use this kind of biofertilizer pellets. The description of these processes can be found in this article here, so you can actually go back and read about the details about this one. Okay, so here this is a biofertilizer composition. Again, we have here the permeate, which is a very clean material, basically after the microfertilization, and this concentrate. This is basically the condensed part of digestate, and here this is the pellets after condensing them using pelletizers. For example, here this is ultra filtered food digestate. So maybe it has actually something like 2.7% of nitrogen, and as I mentioned, majority of this ammonia is ammonia is something like maybe 80% of that, and also it has some nutrients. So basically here, this process can be used for either manure or other materials that actually goes through the digester. Here, this is the ultra-filtered digestate manure, dairy manure. Also, it has lower ammonia concentration and the nitrogen concentration compared with food waste digestate. Basically, manure, of course, has a little of or lower concentration of different elements, except that maybe it has more magnesium here in this case. This is the pellets, basically after the digester, after pelletizing the solid fraction. This is also, we could actually produce digestate pellet with 5% nitrogen, which is good actually fertilizer from food waste, and for dairy it's something like 3% nitrogen. So again, you can actually read more about this here. This is just then we applied this kind of liquid fertilizer to tomato, and here this is just pictures of the ultra-filtrate dairy manure, and this is concentrate food digestate, and here this is tomato without fertilizer, and this is with synthetic fertilizer. As you can see, actually, for biofertilizer, which is these two actually pictures here, the ultra filtered dairy manure and the concentrated food waste, this is basically still green canopy and robust compared with no fertilizer, for example, and with synthetic fertilizer. So basically it was a very healthy plants, and until actually the end of the growth season. So this also here, this is the tomato yield and the quality, and as you can see that digestate biofertilizer produced similar or greater yield and quality than mineral control. And here this is basically the fresh tomato yield. Here this is compared with non fertilizer, of course, is this significant, and here this is compared with UNA 32, which is the conventional synthetic fertilizer. This is still actually the dry manure permeate and the dry manure concentrate. Here, this is basically the yield, and very much actually very similar to some of them actually significant from the UAN 32, and for food waste also it is food waste concentrate. Here this is basically the fresh and the dry fresh tomato yield and the dry tomato yield. This is also still some significant. If you look at the fresh, here this is basically you can find some kind of, there is no significant difference here between UAN 32 and food waste concentrate. The same also here. So basically, yeah, more or less, if some kind of significant difference, and even without actual significant difference, this means that the biofertilizer actually produce similar yield to, or even better similar or better yield to that of produced at the conventional or the synthetic fertilizer. Again, here this is SCBDA, this is chlorophyll, and here this is also still very consistent actually with conventional fertilizer. Here this is a Brix, and this is actually important actually measure. And here this is food waste concentrate, dry manure permeate, and this ultrafilter, this is basically permeate, and this is dry manure concentrate. This also still having better even Brix, which is good actually parameter when people actually I forgot actually to mention this is actually processing tomatoes, which means that it can be processed into paste or other product into in plants, on food processing plants, which means that they actually measure this Brix as a quality attribute of the received processing tomato at these plants. Okay, and here this is again, this is just the percent of total fresh weight. If you look at this one, basically, we can also, this is important actually, if you look at this one, the green tomato, and here's rotten, this is rotten tomato, and here this is a sunburn. If you look at this one, you may actually find some interesting results that actually with digested. Generally, you can find actually a little bit of green here, green tomato maybe, and here this is basically with food waste concentrated you have, and dry manure permeate, you still actually have high greens compared with the control, negative control or positive control, which is UAN 32. And here this is basically the sunburn here. Sunburn also, without actually fertilizer, of course, there is no canopy. This is why you have actually high sunburn compared with the food waste concentrate and dairy manure permeate. Here maybe with dairy manure concentrate, you can find actually a little bit more of the sunburn. Of course, this is again a parameter of the measuring of the canopy of the plant. Again, if we look at this one, this is basically the red or the good tomato for processing, and here this is the greens. This is what we mean actually by greens, and rotten, so some actually, and some burn, so basically the unusable or actually uneatable tomato. Okay, again, this is basically digested tomato, possibly had more greens tomato and less sunburn, except that this is basically for the dry manure concentrate. Okay, with that, I just would like to conclude here that digestate can be transformed into customized solids and liquid digestate biofertilizer with great crop performance, and digestate biofertilizer produce similar or greater yield and quality than mineral control. With that, I would like to thank you, and if you have any comment, please leave it in the comments, and see you next time. Goodbye.